We can get going. Welcome to Engineering and Carbon. My name is Amy Lotzvikoko with the Boston Society of Architects Committee on the Environment, and I chair that committee. And today we're excited to have several different knowledge communities coming together around this fascinating topic. We have the Sustainability Education Committee, the Building Enclosure Council, and the Carbon Leadership Forum, Boston, New England. So our wonderful speakers today are Patrick Murphy, Principal Director of Sustainable Design at Vanderwell Engineers, and Suzanne Robinson, Associate Principal and Director of Sustainability at LeMessurier Engineers. The Committee on the Environment, these are just a few events that we've had this year. We had one on Earth Day, on the AIA Materials Pledge. We had a book talk in August on the Sustainable Urban Design Handbook, which was really fun. We are doing this event today, so excited about that. On the forefront, we're actually going to be joining with the Sustainability Education Committee, and we're doing one on circularity that Thornton Tomasetti has brought forward, and then Jacob Werner is leading one on resilience. We're going to have some other folks joining on that. So good stuff coming up. Just tomorrow, there's a possible vote and on weakening our 2030 climate commitments. And so it's a potential to reduce the mass save funding from $4.5 billion to $4 billion. And I'll put in the link after I stop speaking about contacting your legislator. But this would impact us in so many ways. And you can reach out to me. There's some really nice form letters if you need help with that. We can put that in the chat too. And then just some brief announcements on climate related things. The AIA 2030 peer-to-peer network. I'll drop this link in. For the latest information on design data exchange and what Code National is up to. There's an AIA channel also for climate action pledge programs. So the top 10 reporting has joined with the design data exchange. So we'll put that in. And then the design data exchange is also connected with Energy Star. And we had initial carbon reporting with DDX this year, but it's being improved, and so we have more to do. And then we're now in the third year of reporting year for the materials pledge, which is exciting. The International Institute of Sustainable Laboratories has some upcoming neat things too. A networking event at Ellenswag. It's a recap of the national conference. There's a fee, $35 for that. And January 21st, they're going to do a Boedo and Berto, how those are applied to lab buildings that folks might be interested in. I'll post a lot of this information into the chat. And Felipe.
Hello, everybody. My name is Felipe Francisco. I'm the current chair of the Building Enclosure Council. We meet on first Wednesdays at 5:30, and our next meeting will be December with a presenter being locked down this week. And if you'd like to sign up for our regular emails on upcoming events, there's a QR code, and also paste the link in the chat. Thank you.
Thank you so much, Philippe. And I'm not sure if Jessica or Harshka were able to join, but
Hi, Amy. I'm here. Sorry. Yeah, good evening, everyone. And thanks, Amy, for inviting us to be part of today's events. As Amy mentioned, there's like new developments that are happening with the group. We'll hopefully be merging into the larger code group, and the idea is that we continue advancing like learning and dialogue on green building and climate action stuff within the larger entity. Yeah, and I co-chair the group with the amazing Jessica Wetters, but we'll be seeing how the administrative things work out in the newer format. This year, we did host events like Embodied Carbon, Policy Meets Practice. I think I can add the links to this chat somewhere. But yeah, we are currently regrouping and thinking about the future of the group. But yeah, hope to see you next year with even better better events and more interesting, relevant contemporary topics. I'll pass it back to Amy.
Thank you. And Sunny Dillard.
Thanks, Amy. I'm Sunny Dillard. I'm co-chair of the CLF Hub for Boston Northeast. We're a small hub of the Greater Carbon Leadership Forum. We call that HQ. Our mission is to eliminate embodied carbon of buildings, materials, and infrastructure to create a just, thriving future. And we're really excited about this presentation today. It really sort of goes hand in hand with some of the stuff that we're trying to do with the Northeast Hub. This is a list of the working groups. We've got 8 total, 2 of which have reached far beyond the greater Boston area. If you're interested in joining, you can email me or just visit the CLF website through the BSA. I'm really excited about this presentation, so I won't speak any longer. I'm going to hand it off to Patrick and Suzanne to start the presentation.
Thanks, everyone. Thanks, Sunny. And I just wanted to mention while Patrick pulls up the slides that this, just to reiterate, it is being recorded because some folks couldn't attend. And also there's a link, a form where you'll sign up for if you are doing credits. And I'll be posting that shortly. I'll also be posting some of those climate action items that I mentioned. All yours, Patrick and Suzanne.
Great, thank you, everyone. So today, we'll be talking about total carbon footprints of projects, and especially some of the exciting work that we've been doing in the MEP space and structural engineering space. We know architects have gotten out in front on looking at the carbon footprint of projects. And so now we're doing some exciting new analyses. There's a lot of new information that's coming out of those analyses that we're excited to share. And Suzanne and I, at our respective firms, have partnered together to do some integrated analyses, which we'll share with you at the end of today's presentation. So, hi, everyone. I think a lot of you may already know me, but I'm Patrick Murphy. I'm the Director of Sustainable Design at Vanderwaal Engineers. And with me, I have Suzanne.
Hello, I'm Suzanne Robinson. So I'm the Director of Sustainability at LeMessurier, which is a structural engineering and enclosure firm.
All right, copyright presentation. There's continuing education credit like Amy described. Look for the link in the chat. Today we'll go through very briefly. We trust this audience is a well-informed group of people around carbon in the built environment, but we'll hit on some highlights, especially as it relates to the way that engineers think about it. Then we'll spend time going through case studies and peeling out lessons learned, both from Suzanne's practice and ours, and then also bringing that together in our kind of collaborative work together. And then we'll leave you with some key takeaways for things you can be doing on your projects now to advance the practice. So first, carbon in the built environment. It will surprise no one on this call that buildings are responsible for 40+% of global emissions, and of that, we see about 3/4 of those emissions are associated with building operations, and about 1/4 are attributable to the construction process and the materials procurement and manufacturing process. And what that tells us, when we're only renovating or building maybe 1 or 2% of the square footage in a city or the world any given year, there's a really disproportionate impact around the embodied carbon of projects compared to the 20, 40, 60+ years of operation of those buildings. And so when we're talking about the carbon footprint of a project, we really need to widen the aperture. We've spent many years, especially in Massachusetts, focusing on getting to net zero energy, getting to a real focus on operational carbon to zero. But when we look also at the embodied carbon of these buildings, we need to look at the totality of operational and embodied carbon for that total carbon footprint. And sometimes we may be investing more embodied carbon to save operational carbon. And we need to be looking at that in a really strategic way to make sure that we're making the right choices on our projects. It's similar to, I'm sure a lot of you have been through projects with life cycle cost analyses, where you're investing more dollars upfront for, say, an energy savings measure, say like triple pane glazing instead of double pane glazing, in order to save operational costs down the road. And there's theoretically a payback for that upfront cost investment. The owner wants to see that they are seeing return on their money. You can think of a similar approach with carbon. You're maybe investing more embodied carbon upfront to save operational carbon down the road. Is there a carbon payback? Is that carbon payback quick enough? The teaser I will say is every pound of carbon we are putting in the atmosphere right now is a big deal. And so if your carbon payback is longer than a couple of years, might not be worth it. The time value of carbon is a real big issue, but this is changing the way that we're thinking about total informed integrated design, and we're trying to move this to the beginning of projects to make informed design decisions while we still have that opportunity. So the total carbon life cycle of a project, you've seen the chart before. Embodied carbon are most of the categories around this, and of them, roughly 90% of, at least what we know, of embodied carbon is really happening in the A1 through A3 categories, the material selection and transportation to the site, and actually also the construction in A4 and A5. The operational carbon is just like 1-2 relatively slivers of this project, but it's also a quite large footprint of the total carbon footprint of the project. The way that we get to these quantities, it's just like doing a cost estimate. So you'll see that kind of cost and carbon analogy coming through, where you're doing a material quantity estimate and comparing that to the embodied carbon of that material. Many architectural materials, you're fortunate enough to have environmental product declarations. Speaking as an engineer, those are few and far between for us. So we have other methodologies to come up with a way to translate material quantities into the carbon footprint, the embodied carbon footprint of a material. But then also, especially speaking as a mechanical engineer, the refrigerants that we deploy in a lot of our heat pump systems as part of our electrification strategies have a disproportionate global warming impact or equivalent to embodied carbon. The way we could figure that out is the amount of refrigerant in the system multiplied by the global warming potential of that refrigerant. And the global warming potential means if you were to release a pound of CO2, a pound of refrigerant into the atmosphere, what's the equivalent to releasing CO2 into the atmosphere? And many refrigerants that are fortunately being phased out have the equivalent of thousands of pounds of CO2 being emitted into the atmosphere for every 1 pound of refrigerant that is leaked. So how much leakage you have, the refrigerant selection are big deals. Thankfully, we're seeing a phase out of these highest GWP refrigerants, but they're still a disproportionately high contributor to MEP embodied carbon. When we think about the operational carbon footprint of a project, there are several components that we need to look at kind of simultaneously. There's the site combustion, the scope 1 emissions. Are we burning a fuel in the building or at the site to heat the building, for example? And a lot of our goals are to eliminate that altogether or as dramatically as possible. Then you have emissions associated with the electricity grid. It's a mixture of hydropower from Canada, wind power offshore, solar from down the block, but also the natural gas burning or coal burning power plant across town or across the state that's producing that electricity. There's a carbon footprint for every kWh that you're consuming. You can deduct your clean power that you're generating on site or procuring directly offsite, as long as you're retaining those renewable energy credits, and that gets you your net operational emissions. Suzanne?
I also think it's important to understand the why of why we're learning about embodied carbon as this is coming more into the entry point. One of the presentations I did earlier this year, where we're just educating more engineers across the field, is some of them don't really have climate change on their radar, which is also sometimes the case with some of our audiences too. But it's important to know that it's coming. It's in our regulations, codes, the green building rating systems and stuff. Often the embodied carbon policy shows up in two different formats. So one is the embodied carbon reporting. So this is where we're measuring the LCA. Often we're just asked to report it. That's the entry point, and then later reducing it, usually around a baseline or potentially a benchmark. The easiest entry point is the Buy Clean program. So this is what we'd seen on the operational side with our utility incentives of, a high efficient pump or other new technology. So this is where we're just specifying lower carbon materials, and this often is identified through the EPDs. One of the things that we're seeing in Massachusetts already is the Massachusetts Building Stretch Energy Code already has kind of a quasi buy clean program with the low GWP concrete incentivized in one of the compliance paths for the stretch code. Cambridge and Boston already have in place requirements for the measurement of the LCA, the embodied carbon reporting, for the structure and an envelope in most cases for the buildings, usually over 50,000 square feet. On the horizon, we have the state. Massachusetts had put together an embodied carbon intergovernmental coordinating council to make recommendations to integrate embodied carbon reductions into the state building code. So we'll potentially be seeing some of that in the near future. I know I was involved in some low carbon concrete recommendations for buy clean programs and stuff. So we'll see what makes it to the entry point there. And eventually what we'll see in the future is embodied carbon caps. And so this is where we're starting to see some countries already in Europe that limit the embodied carbon values. And this is similar to what we've already experienced with the operational carbon, right? With our building energy ordinances, which limits the amount of operational carbon you can just have on that building. It's not a % better anymore. It's just a cap. So what we'll do is we're going to go through 4 case studies. So I have 2 and Patrick has 2. We're very democratic in here. The 2 case studies, I had a hard time paring it down. So I ended up picking 2 kind of as a lateral study. They're at Boston University. Before I jump into that though, I do want to just, yes, next slide was talk about embodied carbon reductions for structural opportunities. I'm kind of the engineer in me likes to think in buckets. So as we saw in the earlier slide, we have the material quantity times the environmental impact of a material. It gives you that embodied carbon. And so 2 strategies on the material quantity, we just really want to reduce material quantities. And so that can be done through what the architect designs and then also some of the decisions that the structural engineer does in their design work. And then the other 2 buckets is with the material selection. So you can either specify a lower carbon material, and this is often through improving materials that are already currently in use, such as lower carbon concrete, lower carbon steel, or alternative building materials. So designing with these non-conventional materials that have been around in some cases for quite a while. These are usually bio-based materials like mass timber, which I'll talk about. So jumping into the first case study, this is the Duane family for computing and data sciences at Boston University. This was a project that was awarded to KPMB way back in 2013. And this, I'm making note of the date because embodied carbon wasn't really on our radar back then, over a decade ago, like it is today. In 2017, BU's climate action plan went into effect, and the first 3 goals in that is prepare for climate change, net zero direct emissions by 2040, and act on indirect emissions, so embodied carbon. In 2018, after the project was put on hold, the design team was asked to design to meet these as best as we could, and it was mainly focused on being a very monumental fossil fuel-free building. So in the next slide, the project team was also asked in 2019 to bump up to LEED Platinum. And so it was an interesting exercise because that was when the project team had to go back to the drawing board and look at more credits that they could get up to Platinum. And so there was a whole process of looking at the building life cycle impact reduction credit, which was explored. And through that, we reviewed the concrete design. We're able to develop several strategies, some of which included increasing the SEM, so the supplemental cementous material. This is back when GWP wasn't as much in the forefront for this. We ended up using the highest SCM percentages for some of the structural concrete, 70%, which at that time was the highest. I haven't kept track. I don't know if that is the highest in this area at that time, currently. And then we also looked at a new concrete material. So this was a branded material called EcoPact, which is a blended cement of SCMs and admixtures and such. So this resulted in a 14% reduction in structural material, and the building opened in 2023. The next case study, before I jump into the next case study, I did want to just touch on a concept, gravity path, which I know architects have all taken structures. It was often an early class, I think, for most programs, so hard to maybe digest all of it. But one of the things that is really important is understanding that the simplest gravity path is to have the structural columns all aligning and just going straight down, bring the load straight down to the foundation, nice and simple. That's the least amount of material. So anytime we actually have to have that gravity path travel farther, and this is usually through cantilevers or column transfers, we end up having to use a lot more material to help with that gravity path. And so this project, the data center, is a great example of a building form expressed through cantilevers and open spaces, which you can see here, which required column transfers. So this was on the base level, was a vertical piazza staircase, for congregating that needed a wide open space. So we ended up having a lot more embodied carbon as a result. And I mention this to share that although it's beautiful, it's a design form from like an earlier era. Now that we're becoming more aware of embodied carbon and structure, this was back when that wasn't such a significant factor in the sustainable design approach. And so this is where architects I bring this up on this BSA presentation, where architects have the biggest impact. Like this gives you the biggest percentage reduction of all the strategies I'll talk about. And so it's really about choosing your moments of where are we going to have that expression and making sure we're understanding how we're spending our embodied carbon budget. And so for the next project that I'll have, the Pardee School of Global Studies is a great project because it kind of shows that evolution of how to design buildings that push the limits, but not just in the operational carbon, also looking at embodied carbon and really moving towards meeting BU's, Boston University's evolving climate goals. So this project has gone through several design iterations that we can see on the next slide. And this was a result of basically the timing of the project, to be honest, is this project was designed partly through COVID pandemic. And so as we were trying to meet within the budget, as prices were drastically increasing due to, material shortages and stuff, we were able to redesign as a team while still maintaining the integrity of the vision of the building. So we still have those internal neighborhoods that were part of the design vision and the carbon core. What was interesting with this project is it did not start off with the structural materials that it's ended up with. So it started off with this structural steel mega corner columns, basically. As we were simplifying the design and refining it to meet the budget, we were able to now introduce a new material. And so this was where the project was then able to find a new way to express some of the design vision through mass timber, which is interesting because I always recommend if you're going to design with mass timber, start with mass timber, don't introduce it partway through. But this was again where it was this integrated design approach where we're trying to holistically find something that could meet the vision while meeting all these other requirements. So in the next slide, when we were looking at that initial design, we're really only hitting about a 2% reduction for the structures for embodied carbon. And this was partly not as large because we didn't have as much concrete in this building as we did with the data center due to the design with the project. If we look at the next slide, by adding in the mass timber as an option and the lower carbon concrete, we get a 31% reduction. I will take a moment. Often people are surprised. They think that percentage should be a lot larger. And this is my last point I want to touch on for this case study is in the next slide, if you take it away and you only look at the superstructure, so we're not going to look at foundations anymore, you're actually seeing a 54% reduction. So you're really starting to see that mass timber pulling its weight there with embodied carbon. And actually, if you just look at the gravity system, which the mass timber is, it's 87% reduction. But it's really important, again, not to separate gravity system to gravity system, one-for-one comparison, because you can't do that. You need to be holistic. So for instance, in this project, when we're comparing material differences, steel to mass timber, in our LCA, we do include the acoustic buildup that's needed to meet the acoustic requirements for mass timber that we didn't necessarily have in our previous design that had concrete, which inherently has better acoustic performance. Other fields, for instance, would be in the next slide, is when you're looking at the facades. So often people will try to choose the lowest embodied carbon facade system, and they're not taking consideration the structural system that has to support the facades. So it could be the weight of the facade, the tolerance of the deflection. Those can actually really bump up the structural system. So again, we really need to look at that holistic, everybody's part of the design as we're trying to figure out the embodied carbon for things. I have 10 seconds. So I'm going to add one last thing. This isn't structural, but I think it's a great story, is because we were able to simplify the facade system in this iterative design process, the enclosure system, we were able to now afford a triple glazed enclosure system, whereas before, because it was more expressive on the enclosure side, we couldn't, on the facade treatment, we couldn't necessarily afford that triple glaze. So again, it's figuring out what design moments to put where and where to spend that financial budget and the carbon budget.
So our next case study was the recladding of Gund Hall, the Graduate School of Design at Harvard University, where we partnered with Bernard Cott as the energy consultants more than MEP to understand, what the implications of different envelope strategies would be on the overall project. We were helping in an initial study to scope the project and then track performance throughout the design and construction to ultimately try and address environmental issues with leaking roofs and daylight issues and things like that in the space, but also reduce the energy and operational carbon footprint in alignment with Harvard's goals. So the scope of the project ended up utilizing a hybrid VIG, new curtain wall system and glazing for the studio space, compared to the existing structure, which is a large concrete brutalist, early brutalist structure. The scope of our project was a small percentage of the overall embodied carbon of the project. And this was, not to say that we would have ever demolished and rebuilt the building, but where we're finding value in these historic structures and trying to make them adaptive to the current approaches to design, both in terms of operational performance, but also now in terms of investing our carbon wisely. We wanted to understand what that scope was. So we invested about 160 metric tons of CO2 in embodied carbon in a new facade system for the studio. compare that to the operational savings of the different options that we considered. Initially, when this project started in the study phase, this was prior to the Massachusetts Stretch Code updates, prior even to the drafting of the Massachusetts Stretch Code back in 2022 and 2023. And initially, the goal was to use a high performance but still double pane glazing system. And when the Massachusetts stretch codes came out, and because this project would have to now be subject to the stretch code, it used to not include existing buildings. Then in 2023, it did apply to existing buildings. We had to demonstrate compliance prescriptively with that new code. And the performance values for the facade were about 20% more stringent than the previous version of the code. And so that tilted us towards maybe triple pane, or we looked at this hybrid VAG system as well. And we also looked at applying insulation in other places. We looked at a couple of other strategies, and including improvement in lighting and lighting controls to get overall performance of about 25% reduction in operational emissions. And that's compared to 3 years of meter data. We calibrated an energy model, so we're really trying to be accurate to the real world operation of this building. So we're saving roughly 300 metric tons a year of operational carbon. So when we plot that out over time, over 30 years, we're seeing, compared to not doing anything, business as usual case versus the ultimately installed solution, about 8,200 metric tons of CO2 saved. That's equivalent to the CO2 that could be absorbed by a forest, like 2 times the size of Harvard's campus, for example. So substantial operational savings, but we wanted to look holistically at the investment in the upfront carbon of the project. And fascinatingly, it was the fastest carbon payback we've ever seen in any of our carbon payback analyses. It was under a year. So that upfront investment in embodied carbon of roughly just shy of 200 metric tons of CO2, compared to the significant operational energy savings of that facade, really, it was a slam dunk to make the carbon investment to improve that facade. Now, why was it the fastest that we've ever seen? I think we're limiting the scope to just basically the Achilles heel from an energy perspective of Gund Hall. Really, it was the studio enclosure that was really where it was leaking, both literally and figuratively, a lot of energy. And also, we were addressing a relatively high energy building, an inefficient building before, and it had been served with steam, a more carbon intensive source of heat. And so we really did see that peak load reduction, that heating load reduction, and the reduction in carbon intensive energy. So all of that compared to this relatively tailored scope that we ended up with for the facade really made the approach worth it. Our next case study is a more holistic and focus on the MEP systems approach to total carbon. And this is a teaching laboratory that we worked on with Payette. And this project, when it was initially designed in 2018-19, had the goal of being all electric, no fossil fuel at all. And that reflected kind of the ambitious progressive designs of that era, only 5 to 6 years ago. What we found at the end of the schematic design phase was that we were having a budget problem. And when we dove into why that was, it turned out that the electrical infrastructure costs were a disproportionately high contributor to the costs being high on the project. And so we looked at, well, what other ways could we achieve the operational emissions reduction goal, but also meet the project budget? Otherwise, we would have a project. And so instead of the initial design of air source heat pumps backed up with an electric boiler for the extreme cold days or for loss of power, if we instead used a gas boiler as that backup. So we compromised on the no fossil fuel design, but the operational emissions were nearly identical. And you see that in the kind of overlapping blue and red lines here of, you know, the operational emissions were nearly the same because that boiler rarely came on. It's meant to be for, you know, extreme conditions. From there, you know, we added rooftop PV, we added a parking canopy PV structure to get to net zero. The chart on the right also is meant to illustrate, you know, we didn't just go straight to electrified design and then PV. We really invested in efficiency and load reduction before we got to that. So that kind of simplified, use less kind of approach that Suzanne was talking about was also core to our approach to getting to net zero operations on the project, and also reducing how much PV we needed to add to the project in order to get to net zero. But the embodied carbon of the MEP systems was substantial. So compared to the code baseline approach to an MEP system, maybe like an all air system instead of a hydronic system like we had, and using gas boilers as a source of heat, maybe an air cooled chiller or a DX air handling unit, you know, the MEP embodied carbon footprint of that baseline compared to our proposed solutions, you see a big jump. And really the biggest jump is in this purple category, which is refrigerants. So I talked about refrigerants at the beginning of the presentation as having this disproportionate impact on the embodied carbon of MEP systems. And when we electrify, especially the way, you know, it is still best practice, and the Massachusetts stretch code is written in such a way that is pushing design teams towards electrifying via heat pump, which are refrigerant-based systems. There's a carbon footprint for that. Then we see, you know, the difference between the all-electric and the hybrid were like negligibly different from an MEP embodied carbon perspective. When we added the PV, you see the dark blue on the 2 bars on the right. Now we're adding a lot more embodied carbon. And so the question was like, are we doing the right thing here, you know, to get to net zero operational carbon by adding all this embodied carbon? Fascinatingly, also, the time value of carbon, the payback of all these options ended up being about 3 years, which was also on the early side of the analyses that we've done. We typically are seeing more like 5-year to 6-year carbon paybacks. Why was that? So, you know, when we compare that baseline system and its relatively low upfront embodied carbon investment, but higher operational carbon over time, you know, you see it, this line is climbing quickly, this cumulative emissions over time. All of the strategies that we looked at increased embodied carbon upfront on the left, but reduced how much operational carbon we were consuming over time. And because this was a laboratory, you know, relatively energy intensive facility, you know, that scale of operational emission savings compared to the upfront embodied carbon investment, you know, was a little bit disproportionate and is what resulted in these relatively quick paybacks. Now, I will reiterate the point I made at the beginning. I just showed you a case study where the carbon payback was under a year. Here's some where it's about 3 years. Quite frankly, if when you do these analyses, your carbon payback is longer than, I'm going to say 5 years, you really should question why you're investing that embodied carbon. Because putting that carbon in the atmosphere now to save operational carbon down the road, you know, we have a carbon problem right now. Is there a better use of that upfront carbon? Just putting it out there that we need to really both focus on reducing embodied carbon up front and you know, pursuing operational carbon down the road. So saying that, what would we do differently about this project to reduce that really dramatic increase in embodied carbon for MEP systems? So first, credit to the structural engineer and to the architect. They had already been well on their way to reduce the embodied carbon of the enclosure, the structure, and some of the other site features. That included a cross-laminated timber roof canopy structure that included stone gabion walls instead of retaining walls instead of concrete walls, and lower embodied carbon cement. So you see that like when we add together the interior structure and envelope to the MEP embodied carbon, the baseline to that first all electric, you know, those non-MEP categories go down, but we've invested a lot more embodied carbon for MEP. What would we do beyond that now? You know, it's all these disciplines have to work together to look at the total carbon footprint of a project. That's part of the story. Lessons out of that for us, for MEP engineers, was it's the refrigerant. So this was a selection for a heat pump back in 2019 or so. Now we have the availability of new lower global warming potential refrigerants for our selections, and that alone could make the the total design roughly comparable to the baseline in terms of embodied carbon invested until you add that offsite or the canopy PV in the parking lot. And so by looking holistically as a team, structural, architectural, and MEP at the total carbon footprint, and if you're going to make investments in additional embodied carbon, make sure that you're doing it for the purposes of operational carbon savings, that would be an appropriate investment of embodied carbon in my view. Let's bring it all together. So we're talking as a team. What do we do as a team? And the PV systems themselves are a great opportunity for an MEP engineer and a structural engineer really to partner on how do you think about the total carbon footprint of these PV structures. This photo you're seeing, I'm really jazzed about. We just finished our first mass timber parking canopy structure in the Hudson Valley in New York. So really kind of challenging the traditional approach to these systems. But from a more general perspective, let's talk through the PV embodied carbon footprint. We saw that in the blue bars in my last case study. So the total PV carbon footprint of like a traditional rooftop system, and this is a 1 megawatt system. So these are numbers that you can extrapolate or interpolate for your own project based on the size of your PV system. About 3/4 of that is related to the panels themselves. The PV panels are a really carbon intensive product. And then the remaining quarter is related to the mounting and to the electrical distribution supporting that. Now that's if you put the PV on the roof, but Suzanne will talk us through like when you're building a canopy structure, whether it's above a roof to create, a canopy on top of a roof or to build like a parking canopy.
Yeah, so in this study that we did, we, as engineers, always are like, too many variables. So we set it in Massachusetts. One of the things that we're seeing with pretty much all the code requirements is that you have to design your roof to be able to have the strength to support PV systems. So we weren't counting that on the rooftop PV section. For the canopy PV, the structure does include foundations, and it then includes the structural components that holds the PV system, in this case, structural steel, for things. And so this adds an additional 30% of embodied carbon that we should take a look at when we're looking holistically.
So first, reaction to this is prioritize rooftop PV instead of canopy PV. If you're going to invest your carbon wisely, that should be obvious, but we want to put some numbers on it. So when we look at the time value of carbon, so again, these are numbers that are extrapolatable for a 1 megawatt system. You're making that upfront investment in embodied carbon for either a rooftop PV or a canopy PV structure. And we compare that to if you did not install the PV and you were consuming that electricity from the grid, again, in Massachusetts, what does that look like? So that, no upfront embodied carbon investment, but cumulative over time consumption of grid electricity. The line curves a bit as we expect the grid to get cleaner. And where those lines cross is your payback. And we're seeing, roughly speaking, like 3 to 5 year payback period. Now, we're only looking at a 20-year lifespan. Now, these systems could go 25, 30. It's going to depend on a number of factors. But even under, just a 20-year period, we're seeing that the upfront investment in embodied carbon for these PV systems will pay for itself 3 or 4 times over. So makes a lot of sense in the long run. Also has that relatively short upfront embodied carbon footprint investment. So then wanted to take it a step further. Like, we really need to be pushing, doing better, not just accepting that 3 to 5 years is good enough for a carbon payback. And so from an MEP perspective, one of the things that we wanted to look at is those PV panels are a really disproportionate contributor to the embodied carbon of these canopy systems or rooftop systems. And so there are products available, even American-made ones, and especially like thin film PV panels that have somewhere in the range of 60 to 75% less embodied carbon in those panels than the traditional ones that you're procuring. And then on the structure, Suzanne had other thoughts.
Yeah, so structure, we can do the lower carbon concrete material, really push that down for foundations. And then for the superstructure components, looking at mass timber potentially, or steel, a lower carbon steel, which is more than just recycled steel. That's kind of business as usual, but something that really pushes that GWP down.
So looking at the time value of carbon again, like the traditional canopy PV that I showed you earlier versus this best practices approach to embodied carbon investment in PV canopies, again, versus the operational carbon consumption of the grid. And we're seeing that carbon payback reduced by more than half. And so that carbon payback is now roughly 2 to 2.5 years for the kind of optimized approach to total carbon for your PV canopies. So we can do better. We should be pushing to do better. And the carbon payback over time, instead of being 3 or 4 times, is now 7 times. The operational carbon savings of installing the system has paid for itself 7 times over instead of 3 or 4 times over. So key takeaways for you to take from our discussion today to your practice. Really, we're emphasizing this holistic look. It's multidisciplinary. It's also looking at all the carbons, the operational carbon and the embodied carbon, and making sure that you're making strategic investments in embodied carbon that will yield operational carbon savings so that you're reducing the total carbon footprint. And when you work across disciplines, maybe trading them against one another to, say, offset the investment in additional embodied carbon for, say, your refrigerant and a heat pump with maybe structural embodied carbon savings, there can be a leveling of the total carbon that you're going to invest upfront in the first place while still recognizing that long-term operational carbon savings. Suzanne? You are muted.
Of course, trying to be quiet over here. So when we were discussing this presentation initially, one of the things that helps me is the guiding questions of what would the audience want, assuming mostly architects. And, what's the number one thing an architect can do that has the biggest impact? And then I was also thinking what is it as engineers we get frustrated with architects about sometimes too? And so part of that is really just being involved, working collaboratively, but from early stages. So not just SD, but even pre-concept, when the image of the building is being imagined and being presented to the client, is really helpful to be able to be a part of that discussion. And it has the biggest impact. It has the biggest impact on total carbon, and then also the budget. Everything can start aligning there. And so that leads to the third point is through the work that we've been doing through the discussions, through kind of collaboration and all, it's really understanding, you know, how to strategically invest financially, which we're used to over time, but also how to strategically invest in embodied carbon, in our total carbon picture, really. And so it's understanding, where do we want to have those moments for embodied carbon? We're not going to not have buildings that have cantilevers and column transfers and stuff, but like really focusing, okay, where do we want to spend that money, just as we would with like a finish or something like that. And then potentially, as we're simplifying some of the embodied carbon, we're able to save because it's got a direct correlation often. And we can actually apply some of that financial savings towards other carbon initiatives, whether we're piloting new materials to try to move that into the mainstream or something on the operational carbon side. It's really about choosing where we spend our carbon budget. And I think with that, I'll wrap it up so that we have a little bit of time for Q&As. I saw some good questions in the chat already.
All right.
Thanks,
Sure.
Suzanne and Patrick. That was wonderful. I might love to kick off with a question if that's okay. Although I will acknowledge somebody named HRD mentions that you can consider rain screen facade PV as a dual purpose solution. I was wondering, I guess it's a question to both of you. When you're doing your analysis, are you using one-click LCA? Is it in Office? Are you using Athena? Are you using Tally? Just like, and are you working with the architect? Are you plugging into your, putting it in your model? Like, how are you guys doing that?
Suzanne, do you want to start and then I'll take
I
it?
will start. I feel like, Amy, I have not talked to you until today, but I feel like you're a plant for me. So the analysis we did, we used Tally. However, one of the things I'm starting to see is LCAs, because they're relatively simple, they're not like energy models that are so multidimensional. It's the material quantity times an impact value. So we're seeing a lot of that being done in isolation, and I'm surprised how much the engineers aren't even consulted or involved in it. And as a result, we're seeing huge swings on what those LCAs come out to be. So one of our internal initiatives is figuring out, how do we do QC on LCAs, whether it's an internal QC we're doing or we're involved in a project and, you know, reviewing someone else's QC. One of the things that we've done at LaMeasure as part of our SE 2050 commitment is we have to report a certain amount of LCAs for projects each year. We've used that opportunity to actually, every engineer, we hit a milestone this year. So every engineer, aside from our leadership, has gone through and done an LCA on at least one of their projects so that they understand what that process looks like and they're better able to communicate and have that conversation with the team, even if we're not doing the LCA.
That's great,
So-
Suzanne. And did folks do it in Tally?
And so we do it in Tally, is
Yeah.
the current tool that we're using.
Sorry to speak over you, Patrick, please.
No problem. So on the MEP side, the problem that we have is that up until not even a year ago, there was no tool for us for MEP. And so I really want to give a hat tip to Ryan Murphy, who's on this call, who not only like actually produced the presentation that you saw today, but also has built a custom tool that we're using to quantify embodied carbon. We're also...
Oh, did we just lose Patrick?
I think we may have lost Patrick.
I think we
Ryan, do you want
did.
to take it
Yeah,
from there? That's your
but-
cue, Ryan. That's your pickup.
Sure, yeah, guess so. Yeah, Ryan Murphy, also working at Vanderwild, no relation to Patrick though. Yeah, we've just been developing a tool to be able to quantify MVP body carbon emissions, both in the early stages of the project when we don't know the exact material quantities yet, we don't know the exact layouts of the piping and all the ductwork and all of that. That's when we have the largest impact on the design. So we want to be able to quantify that with, you know, an estimate early on, and then eventually as the design bids out and we have proper models, we can, you know, make that a more accurate estimate by the end of CD. There is one quick LCA that does have an MVP embodied carbon functionality now. We have looked into that and used that a little bit, but just in the early stages of the project, we don't know all the specifics that will need to go into that tool. So we find it to be more of a, you know, later kind of evaluation tool at this point.
Thanks, Ryan. Here's Patrick. Patrick, that was a perfect segue. Ryan was able to answer the question to finish the answer to the question. So perfect timing.
Thank you. I'm sorry, there was a IT issue right there, but I'm logging back into my computer.
I have a second question, but I want to just scan the room for other questions. Okay, I'll hop right in. For the air source heat pump project with electric boiler, where you had the gas, modify that to a gas boiler as backup. Would that be possible in Cambridge and Boston now?
That is a great question. And the short answer is that in a specialized opt-in code community so Boston, Cambridge, and several others, that you have you have 3 paths for a non-residential project to comply. You have net zero on site, you have a mixed fuel building, or you have an all-electric building. The all-electric path allows you to have a gas backup system as long as your all-electric solution, which utilizes either an air source, ground source, or exhaust source heat pump, is your source of heating down to the design condition. So if you have like an extreme cold day, like we had that like negative 13-degree day a couple years ago, like you can have a gas boiler for that, for example. But frankly, even an electric boiler is not permissible for the all-electric path because it's not as efficient as a heat pump. So in those specialized option code communities, we're talking about like redundancies for extremes where these systems are employed, and we utilize that on the project on the Cape because power was less reliable out there, quite frankly. And so we needed to have like a reliable alternate source.
Thanks, Patrick. Oh, we lost him again. There is.
I'm still here. I'm still here. I'm switching devices.
Oh, very good, very good.
Recording in progress.
Yeah. Other questions? Oh, Tom Beresford has a loaded question that may be outside the scope of the measure of Van der Waals work. Has an LCA been performed for a generic passive house building? How does the time value of carbon look? Is the payback greater or less than 5 years? This is relevant, of course, for all housing in all Massachusetts stretch code jurisdictions. And Tom, I'll just say that it's a really good question, and like I did a tour of the passive house Massachusetts president's his own house that he designed, and to meet the path using the PHPP, his calculations, he did 10 inches of insulation under the slab and of rigid insulation, and that's like just to get the PHPP to work. And that was such an embodied carbon hit, so lesson learned there.
So and that is a really good question. I actually just had a conversation with somebody I won't name, but like I really trust in the embodied carbon space. And we're talking about this idea of carbon payback and what's a good use of it and what's a bad use of it. And one of the things that we talked about was using embodied carbon as a reason to not add insulation is a bad use of a carbon payback. That you shouldn't be afraid of investing embodied carbon for operational carbon savings. Also, you should challenge, like we were trying to show in our examples, that doesn't mean that you're adding bad insulation with high, global warming potential blowing agents or things like that. Like, you need to look at the totality of what your approach is. So I have not seen a passive house carbon study. I would love to see one. Initially, when I saw my admitted like first reaction to seeing the code updates or to seeing and including pushing passive house, or also just like the really stringent glazing and insulation requirements and assemblies, was like, ooh, I hope that doesn't backfire by engineers and architects like taking the easy route of like just using what they know and like adding triple pane glazing or adding insulation like XPS for roof insulation because they just need to hit this number, without thinking about the carbon footprint of it. Like you can get to these values in different ways. The gun hollow example is like utilizing a hybrid VAG system, which is still functionally 3 panes of glass, but like, you know, like really being intentional about it. And we can have it all, but it does require that, you know, holistic thinking.
Yeah, and I think I'll just add, I put something in the chat. A link is really building on what Patrick is saying is, again, thinking of like a carbon budget, right? So we still want to hit that operational carbon, that embodied carbon of Passive House. But how do we hit that carbon number? And so maybe this is where we start seeing, you know, the bio-based materials start playing that role. So there's been a lot of uptick in interest in bio-based materials because it's helping fit that gap, right? That we're seeing with our conventional materials now that we kind of understand embodied carbon better. Oh, wait, if we're really going for like a zero carbon building for embodied carbon and operational carbon, how do we get there? We can't do that with our current tools. So how can we get there further? So this is a project that just came onto my radar. We were not actively involved in it, but it's a housing where they used a biocomposite wall. So that is helping both with the insulation side, but also helps with the embodied carbon side too. And a big shout out to Timber HP, which hopefully will be making it through. I'm glad to see that come back in. But again, it's how do we start getting some of these new materials into projects? So one of the things I'll say, I had to cut some case studies. I wanted to spend maybe 4 hours talking on this topic, is really using opportunities to pilot new materials where it's not we're using this material everywhere, but finding a little spot. So, because what happens is our biggest obstacles is perceived risks. So often it's not necessarily cost, it's the risk associated with the new material. So if we can just test that out, that helps owners see where it's been used before. It helps contractors get familiar with the product. This includes like newer, lower carbon concrete materials and stuff, even if it's just in a critical little spot on a project, I think is so useful.
Well, unfortunately, I have to hop to my 1 o'clock, but thank you, Suzanne and Patrick. That was wonderful. And Patrick was able to just post, I think, and we're going to email you this file that Patrick is posting. It's going to come from the BSA after the event. So thank you.
Wonderful. Thank you, guys.
From